Hi, this is Leetcode question, partition list. To solve this question, what we will do is create two lists. The first list contains nodes that are less than x, and the second list will contain nodes that has values greater than or equal to x. So the first node or the first list, the head of it is h1 and t1 is pointer to the last node, which is the tail, and the second linked list has the head h2 and the last node is the tail t2. And after doing that, we will merge the second list to the first one. So after merging, comes like this. So this is T2 and this is H2 and this is T1, this is H1, and this is the head of the final linked list, and we return H1. Notice this part contains values less than x, and this part contains values greater than or equal to x. Let's see how can this work from the example. Initially, all the pointers are null, and we iterate until the head is null, which is the end of the linked list. And the idea will be the node that has value less than x will be we will try to append it to the first list, and the node that has value greater than or equal to x we will append it to the second linked list. So the first node, this one is less than x is 3, so this condition apply. Now the header is initially, or h1 is null, so this condition apply. We will assign the head and the tail h1 and t1 to point to the first node. Then we move the head, so the head initially was here, this is head, then we do head next, so now this is the head, and the value is 4 is greater than x, that means 4 will belong to the second list, and again h2 is null pointer, so this condition apply. In this case h2 and also t2 will point to this node. Then we move the head, the value is 3, which is greater than or equal to x. In this case, this node will belong to the second linked list. Now this condition apply because h2 is not null, and we do t2 of next equal head, so t2 next equal head, so this will point to this node, to the head, and t2 equal head. Now this is the tail of the second list. Then we move the head again, so this is the head, and the value is 2, which is less than x. In this case, this node will belong to the first linked list, so h1 apply because h1 now is not null. t1 of next equal head, so the next of this node is the head, and T1, the tail of the first linked list, now equal to the head. This is T1. Notice that H1 and H2 will not move after the first step. Next is head next, which is this node. This node has value 5, which is greater than 3, so this node clearly belongs to the second list, and this condition apply. T2 of next, the tail 2 of next equal to head. Let's do it from this part, and T2 equal head, so this is T2, which is the tail of the second list. Next is this is the head. The value is 2, which is less than x. That means this node must be part of the first linked list, so this condition apply. T1 next equal head. Now this is T1 of next equal head, and we move the tail to point to the head, so this is T1. Next head next is null, so we break this loop. Now let's see how H1 first linked list is contain 1, and from 1 we go to 2, and from 2 the next is 2. Notice that this link here, that means the next of 1 is pointing to 2, so this implicitly is removed, and T1 points to the last 2. The second linked list start at 4, which has the head 2. Four points to 3, 3 points to 5, and T2 points to 5. Okay, now we need to check if first if H1 is null pointer, because in that case all the nodes in the original linked list are greater than or equal to x, and this condition means all the nodes in the original linked list are less than x, so we don't need to do any merge. Now let's append the second linked list to the first one. T2 of next first equal null pointer, so this last node should point to null as the end of the list. T1 of next equal H2, so this is T1 of next equal H2, point to this, and so after this merge we will have 1 2 2, then we have this connection 4 3 5. This is T2, this is H2, and this is H1, this is T1, and at the end we return the head of this linked list here, this 5.2 null. So we return each one as the final answer, and as you can see 1 2 2 4 3 5. So the output is 1 2 2 4 3 5, and the time complexity is big O or n, where n is the number of nodes